I'm going to show you how I would do this question. Can I just say this? There is not that many straight differential calculus questions, because a lot of the time it's differential equations, chapter 8, or applications of integration, these sort of things. But if you can't differentiate, you can't. Yeah. If you can't differentiate, you can't anti-differentiate. Okay. Now we're starting at 23 seconds. We've got 3 marks. It's going to take 4.5 minutes, but let's see what we can do. First of all, we can say that I'm going to just do this. I'm going to just say that f dash of x is equal to, I'm going to apply the chain rule in my head. What is u? U is 2x. What is the derivative of u? 2. So I'm going to therefore multiply the derivative, du dx, times y is equal to arctan of u, which is the derivative of that is what? 1 plus u, 1 over 1 plus u squared, where u is 2x. Can you see that you can actually do that in one line and you do not need a method mark? Okay, that's where I eventually want you to go. Okay, so therefore f double dash of x, we need to then apply the what rule? 2 over 1 plus 4x squared. Yeah, the quotient rule, isn't it?
You just use,
you could use the product.
Can you use chain rule and just say that that's 1 plus 4x squared all together?
You can. Yep. Well, that's actually the product rule.
Yeah.
Yeah. So therefore, I can therefore say that if I've got f dash of x is equal to 2 over 1 plus 4x squared, let's do it this way, that we're going to say that that is equal to 2 outside of 1 plus 4x squared to the power of negative 1. I'm going to then apply the quotient rule, the product rule. The derivative of 2 is 0. So therefore it's not that. And the derivative of 1 plus 4x squared to the power of minus 1 is equal to, well, what do? We therefore say that I'm going to do f double dash of x. Now you can do this without showing you're working, all right? Because they know that you're applying it. The derivative of 1 plus 4x squared using the chain rule is 8x, okay, 8x times the 2, 8x, and then that is 1 plus 4x squared to negative 2. And you've got to multiply it by, because you've got to bring the power out the front, times it by negative 1. So therefore, we've got that's, can you see there that it can be really tricky? That's why sometimes it's better to set it out with your u's and your v's and doing it that way. Okay, but I'm just showing you eventually what you can do as a minimal for the exam to please them. Minus 16x over 1 plus 4x squared. That's f double dash of x. Make sense? Okay, so therefore f double dash of 2 is equal to pi on 2, sorry, I'm rushing now, is minus 16 on pi on 2 is minus 8 pi over 1 plus 4 x squared. X is pi on 2, so pi squared on 4, so that's just pi squared, isn't it? So it's 1 plus pi squared. And to be honest, you don't have to simplify that anymore. You can leave it as that. Now, I've done that in about 3. Now, I just wanted to discuss this question. The answer is correct. Our answer is correct. Have we skipped any steps? No, we haven't. But I personally can do that in those steps. If you, when you're doing your practice questions, are not, then you need to actually apply the chain rule appropriately. Let u equal this and so on, and apply it and actually take a few extra steps. It might take you the whole 4.5 minutes, but don't be in the 58% of students that got 0 or 1 mark. It says a large proportion of the students were unable to find the first derivative correctly, despite the assistance of the formula sheet, because it basically just had to find the formula sheet. The chain rule was often not used, which I said you need to use it, because the people that look at the formula sheet, the people that look on the formula sheet will just see that the derivative of inverse tan of x is 1 over 1 plus x squared. And then they won't realise that the derivative of inverse tan of 2x is 1 over 1 plus 4x squared. Okay, so a number of students didn't recognise arctan and 2x as being an inverse circular function, but interpreted as being a reciprocal function, all sorts of things. Look how poorly that's done, but not many students even got 2 marks. They either knew what they were doing or they didn't. Okay, now that was a straight differential calculus question. I'm now going to give you another one from the 2009 exam, which is like a verify question. It's using derivatives and double derivatives, but it's y equals e to the mx, and you've got to find the values of m. It's only worth 2 marks, so you've got 3 minutes. I'm going to give you 4 minutes. Okay, away you go. Go. All right, so this question, I've given you a chance to do it. I'm going to do it as quickly as I can. So therefore, I'm going to say that y is equal to e to the mx, and I'm going to let dy dx is equal to me to the mx, and I'm going to say that day squared y dx is equal to, m's a constant, so it's m squared e to the mx. Now I'm going to therefore verify. It says find all the real values of m such as this. So therefore we're going to say that m squared e to the mx minus 3me to the mx minus 10e to the mx is equal to 0. Now what I'm going to do is I'm going to take e to the power of mx as a factor. M squared minus 3m minus 10 is equal to 0. I'm going to divide both sides by e to the mx. So therefore we can say that m squared minus 3m minus 10 is equal to 0. So therefore, can I use the quadratic rule, or can I factorise? I can factorise. I can say that m minus 5, m plus 2 is equal to 0. Therefore, m is equal to... Now let's have a look at the question. Find all the real values of m. Yep, that's fine. M is equal to negative 2 and 5. Is that correct? Yep. Yes. How long did it take? 5 minutes 38 it was, so less than 2 minutes. Yeah? I've just bought myself 1.5 minutes in the exam. Or what's that?
Yeah, but it's
3 minutes. Yeah, but I was at 5 minutes and 38 seconds. There we go. Now, first of all, we're going to do this question. I'm going to do it really quickly, and it's got 3 marks. So what we're going to say is I've got f of x. I'm going to write it again. F of x is equal to inverse sine... Is equal to... Is that 2 on pi out the front? 2 on pi inverse sine of a half x plus 1 minus 3. What I'm going to do is I'm going to let u... Do this the long way, ladies and gentlemen. Let u equal a half x plus 1. Therefore, du dx is equal to a half. Y is equal to 2 on pi inverse sine of u minus 3. Dy du is equal to, well, we've got 2 on pi outside of 1 over the square root of 1 minus u squared. Is that correct? Okay, so therefore, applying the chain rule now, f dash of x is equal to this times this, which isn't that those 2's going to cancel out? 1 over pi, the square root of 1 minus u squared. 1 minus u squared. Now, u squared is a half x plus 1 all squared. Okay, now we're not done yet because look, it's in this form. This was one of the hardest questions in recent memory of exam because of their algebra really was bad. Okay, so I'm going to finish it off really quickly. Yeah? Yeah, but when you differentiate... Yeah, okay, I've just skipped a step there, but it's not necessary. 1 over pi, and then in the square root sign, I'm going to say that that's 1 minus 1 squared minus 1 minus a quarter x squared, half x plus a half x, x minus x, isn't it? Okay, they're going to cancel out, so therefore we've got 1 over pi square root of x outside of, and maybe we've got a quarter, x over 4. And then that's what? Let's do negative x over 4. And then that's x plus 4x. Is it? It's not plus 4x, it's plus 4. Thank you. Now, are we done yet? We've got to simplify it, which is 1 over pi, and then this, a half comes out the front, but 1 over a half is 2, which is 2, and then that means it's 2 the square root of minus x, x plus 4. Is this in the format we want? Yeah. So the answer is 2 over, now you need to state what A, isn't A 2? B is equal to what? Negative 1. C is equal to 4. And if I go to the examiner report of 2010, I'm going to pause that video. All right, so you can see here, yeah, it was. You can see here that A is equal to 2. We've got that there. We had that? Yep. So 56% of students got 0 or 1 mark, but I want you here, yeah? Good stuff. Thanks for today's lesson. That was really good.